Hi everyone, this is Professor Benjamin and welcome to session 10, where we're going to cover population. So as always, you start off with the description of the week. So here it is, and there are two textbook chapters related to this. So there is chapter 2, population ecology, and then chapter 3, which is human demography. So it's really important that you read both of those chapters for this session. So there's a lot of reading for this session, especially in that OER textbook. But there are also additional articles and videos that I need you to read in terms of population. So let me get to population again. Here we go. Here we are. So here is the description. Here's the textbook. So remember the two chapters. There's the PowerPoint here, and I'll walk you through a little bit of that in a couple minutes. But the PowerPoint, of course, is important. And remember, below the PowerPoint are notes on it. Then there's a couple readings and videos. So number one, there is the podcast 7 billion and counting. Can Earth handle it? You do not have to listen to the entire podcast because it's a long podcast, but it's a really great podcast on can the world actually support a 10 billion human population. So there's a lot of questions to be asked. Number one, we hit 7 billion in the fall of 2011. We are currently at 7.8 billion. So it took us about 9 years to get to increase the size of the population by 0.8 billion. And this video, which is really great, it's a very small, short video, but it's an awesome video that shows you how the world's population can exponentially increase so quickly. And of course, it has to do with advances in medical technology, advances in sewer systems, like access to clean water, access to sewer systems. All of that plays a role in why the population was able, and better access to food. And that's why the world's population was able to double in such short periods of time. And there's a really great graph in the PowerPoint that shows you how we've kind of tripled our population in specific periods, like the agricultural period versus the industrial period. So make sure you look at the PowerPoint for that. It's really important. But the prediction is that we'll reach 10 billion by 2057. So we should reach 10 billion by 2057. And this is a big deal because a lot of individuals, a lot of environmentalists say that that's the breaking point, or what we call the carrying capacity line for human population. And what do I mean by that? Is that there's a line, there's a tolerance level that the Earth can handle. And what happens is that once we exceed that carrying capacity line, individuals are more subject to death through lack of access to clean water or food or proper hygiene, etc. So that is the big issue, is that usually let me just pull up, I'm going to show you a little graph. So here we go. So here's a typical ecological carrying capacity line. So what happens is that populations decrease, which we've seen this. Then you see this J curve here, and we call this a J curve. Starting here, you can see it's in the shape of a J, right? And a J curve is that exponential increase. This line would be the carrying capacity line, and this is what we consider the line that supports the population. Once you go above that line, okay, in terms of exponential growth, you see what happens is there's going to be a die-off at some point, meaning that the Earth can only support so many individuals, and then once it reaches that carrying capacity line, and it'll explode over it, so you won't feel the ramifications right away. It's not as if in an exponential growth, you get right to the line and then people start dying. No, people explode over the carrying capacity line, and then the Earth can't support the resources that they need, and then there's a die-off. Now, what that die-off is from is very disputable. And this is really an interesting time, because for years I've been talking about a virus that could definitely wipe the human population back. Remember, there are all checks and balances within Earth that we can't control. And a virus could be one of those, which is a virus that really because of close living conditions, other things, the virus spreads really fast. And then what happens is that that carrying capacity, there's a huge die-off. And what usually happens is the population dies back, and then there's actually usually like a line that goes up and down to where it becomes kind of more viable again. And you'll see this with other species too. Like, let's take a deer species. Or a fox species. Let's do a fox species, because I used to do fox research studies when I was in undergrad. So fox populations explode, especially on islands, island areas. Jersey Shore is a great example of this. The fox population explodes because it has no natural predators. So once the wolves or coyotes were taken off of the area, so it was really coyotes in New Jersey, they were removed from the area. And then what happened was the fox population exploded because there were so many rabbits on islands. And then what happens is the fox population gets so big that they eat all of the rabbits, and then there's no food source for them. So then what happens is the fox young start dying because there's not enough food to feed them, and then it kind of goes back. The rabbit population comes back, the fox population then comes back. And this is all part of that ecological cycle that we talk about. And in this case, that's exactly it, is that there's talk about the human population exploding over the carrying capacity line. There wouldn't be enough resources, food, access to clean water, hygiene, etc., medical care, right? Not enough medical care to go around. We've seen this here in the United States during the COVID outbreak, right? Not enough medical care to go around. The population dies back, and then it kind of moves back and forth until it kind of evens out again. And usually for a period of time, we stay right below that carrying capacity line before any changes sort of take place, whether the population dies back after that or goes above that. So that's something that is very essential, a concept that's really essential to this session in terms of population. And then this is really good. So this is the essay on Principles of Population by Thomas Mathis. You don't need to read the entire article, but Mathis predicted that there would be a die-off of the human population. But the problem is Mathis didn't realize that we were going to have like industrial agriculture. We were going to feed so many people with the agricultural systems we have. Now, that doesn't mean it may not come true, meaning we have a lot of pressures on our food system, meaning we grow monocrops, so we don't grow biodiversity, a biodiverse crop selection. So we very well may have an issue where the entire food system has a lot of stressors and it could collapse on itself. That could be a big issue, whether it's a virus that affects cattle or a virus that affects pigs, which we've seen, like the swine flu, etc. Could kill off, we've had this with chickens too. We've had viruses that kill large amounts of chickens. This definitely could happen. And then the whole entire system would collapse because these chickens are raised in close quarters together. All of our cattle are raised in close quarters together. All of our swine are raised in close quarters together. It could affect an enormous amount of our meat system in like one fell swoop. So that's really important to know about and think about. Just because his prediction has not come true yet doesn't mean it won't come true. The other things are ways in which we've tried to combat overpopulation of humans. So countries implement different ways to try and combat overpopulation. And China tried to do this, right? Under General Mao, they tried to implement, well, they did implement the one China child policy. But what happened was they just totally didn't realize all the social consequences that were going to come from it. And the one China child policy was a policy that was enacted. And what it would do is that it either in some areas, it limited you to have one child, but in other areas, it taxed you for having more than one child. But what the underlying issue in China is that boys are worth more than girls in terms of they carry on the family name. They are the social security system for older adults. There's just a whole different culture involved. And with this came a ton of social consequences. Girls are hidden in villages. Girls were aborted at enormous levels. Even though they outlawed ultrasounds, there was a black market for ultrasounds and girls were just slaughtered. The other thing is that girls are trafficked because now there's way more boys than there are girls in China. A lot of the government now has to take care of lots of girls in orphanages because people just left them on the wayside because they didn't want to be taxed or they could only have one child. It also created a culture of boys in China being what they call little princes, is that they're overfed, they get their own way because they are the only child and they are coddled. So there's a lot of social consequences, and you can read about all those social consequences here in terms of China. Also, their economics are suffering because China, right, is one of the larger manufacturing countries in the world, and now, right, they don't have a big enough population to support the economic growth that they want to have. So it definitely crippled their industry sector by not having as many people as they needed. Now you could think about this from an environmental standpoint and say, well, population is better with less. So there's a lot of stuff going on here in terms of the session. In terms of population. Now, the U.S. and most developed countries are at 0 to negative population growth. That means our population will not grow. In fact, our population will start decreasing significantly after the baby boomer population dies. They were born after World War II. That's when the population exploded. Right now, in the United States, we're about 1.8 per 2 people. So meaning 1.8 children are born for every 2 people in the United States. That's negative. That's a negative population growth. And there's a lot of reasons for this. And mostly it's because of women. Freedom of women, women in the workplace, access to contraceptives, all of this plays a role. Cost of childcare, all of this plays a role in why the U.S. population is not astronomically increasing. That's not to say that in the future, there has been talk about giving tax breaks, right, to have more children. Because remember, less people, less money is going into the Social Security system. And remember, the baby boomer generation is huge and they're sucking from the Social Security system. So that's why a lot of people say we won't have any Social Security when we get older, because that baby boomer population will suck the Social Security system dry because there's less people putting money into it because there's less of a population. And this is where immigration is important, is that if we legalize a large amount of illegal immigrants, our population could increase and it could feed that economic system. Now, again, there's a lot of environmental issues with this, meaning more water per person, more food per person, more housing. All of those things affect the environment and our urban ecosystem. So there's a lot to think about up and down, okay? So there's a lot going on with population this week. And if you look, don't forget, so initial post due by Wednesday, response post due by Friday. But look here, you already have your review for the final and a walkthrough of the final because we are headed towards the end of the semester, okay? So have a fantastic week, and I hope you enjoy this session and learn a lot about population. There's so much to talk about in terms of population. And if you have any questions or you want to share anything with me, I'm always open. I'm more than welcome to hear from you. So please share with me whatever you want. We'll have water coming up, and then we have non-renewable and renewable, and then we are done for the semester. So looking forward to a good semester towards the end of the semester, and don't forget population this week. Have a fantastic week.